Hey everybody, welcome to video number 2 of graph analysis. In this question, we are going to be finding out when a function is decreasing. This time, as soon as you see the word decreasing, you should think we need y prime is involved. And I put a circle in that. Yeah, so anytime you have a decreasing or increasing function, or you're trying to find minimax points, that's when you know you're going to be using y prime, the derivative. So guess what? We're going to have to find the derivative before we go anywhere. Be careful because if you make a mistake early, it really wrecks the question. And if I spent hours making them up, then you've just destroyed my beautiful question. All right, so we need the quotient rule. Quotient rule for your memory is derivative of the top times the bottom plus, not plus, minus the top. Sorry about that time waster. Times the derivative of the bottom, all over the bottom squared. Many of you on your quiz forgot the bottom squared. So the derivative of the top is 2x times the bottom left alone minus the top left alone times the derivative of the bottom, all over the bottom squared. Okay, I think we're going to need to simplify this. I normally teach you to common factor everything here, but this one is fairly easy to expand. There's no big exponents or anything. So we're just going to expand this one. I think you get 8x on the top minus 2x cubed. And be careful, in the next term you have a negative and another negative. So it's going to be plus 2x cubed. And negative 6x negativized is actually plus 6x. All over 4 minus x squared squared. And that simplifies nicely, actually. The cubic term dies, and you end up with 14x over 4 minus x squared. I debated whether I should make this one a bit more tricky, but I thought that it might be tricky enough for our first example. Okay, so now we've got y prime simplified. So now you're going to notice that there's a lot of similarities between what we did in the previous question, which you can kind of see over here, and this question, and the next question too. So what you do in all of these cases is you find out when the item you're looking at, in this case y prime, when is it equal to 0? Uh, and that's when top is 0, and that's pretty easy to see. It's when x is equal to 0. Then you find out when y prime is undefined or infinite, and that's when bottom equals 0. I'm not sure I wrote that in the previous question. You're looking for when they're both, the top is 0 and the bottom is 0. They mean two totally different things, but they're both really important. Actually, I should talk about that now. We'll do it in a sec. Okay, so the bottom is 0 when 4 minus x squared is equal to 0. Don't worry about the other squared because 0 squared is still 0. And this, hopefully you can see, will have zeros at. I'll show the work. I'm not going to be lazy here. Don't forget the plus or minus. So the reason we found these points is because when we are trying to find out when something switches from increasing to decreasing, it has to first either hit 0 or hit infinity. I mean, there is a possibility of a hole or something like that, but certainly something strange has to happen at those points, and the only places where that can happen are at intercepts or vertical asymptotes or possibly a hole. So that's why you got to find those points because they become the important points that go in our wonderful chart. Notice in this case, I do not need to do anything with y. Just like in the previous one, we didn't touch y prime or y double prime because they don't need it. So that's one of the most foolish things people do is they do a whole bunch of work they don't need to do. So here you put in your important points, -2 and +2 and 0. Put in your zeros and your infinites. And then that tells you I have these 3 points. All I have to do now is check in the intervals in these 4 gaps here. And you can check any point in between and that will tell you what's going on. So first of all, one thing you should notice is bottom is always positive. Always positive. So we don't have to worry about the bottom at all for any of this. So that's really, really helpful. In other words, whenever x is positive, the top is positive. So this is going to be positive over here and over here. If you don't believe me, shove in a number like 100 into here, you'll get 14 times 100, which is positive, and 4 minus 100 squared. That's definitely going to be negative, but then we're going to square it. So the top's positive, the bottom positive is going to be positive. On the other hand, if you put in any number less than 0, any negative, the top will be negative, and once again, the bottom will be definitely positive because it's squared. So these two terms, these two intervals are going to be negative. Okay, so here's the point in the question where you ask yourself, what was I looking for again? I'm looking for when this function is decreasing. So to do that, you know that it's decreasing when y prime equals, is less than 0. I'm sorry, I can't leave that. I have to make it prettier. Yeah, so for those of you that don't remember and or were away, if your derivative is less than 0, that means your tangent looks like this, which means your function must go something like that, or possibly like this. But that means in both cases it's decreasing. So this is somebody's mark dropping here. So that's what tells you when you're looking for a decreasing. It means that its slope must be negative. And so now we're looking for the two parts on the chart here that are negative. Whoopsie, sorry about that. Here and here. And to describe those two regions, you say y is less than negative 2, or negative 2 is less than x is less than 0. And if you didn't catch it, it's not y, it's actually x. Those are the two regions. And if you wanted to write them the other way, you could. X is a member of the interval from negative infinity to negative 2 in union with negative 2 up to 0, not including the endpoints. Okay. In most of these questions, the endpoints won't be included because we'll either say above or below the axis, decreasing or increasing. What's happening at these other points? Well, that's a good question. I'm really glad you asked. What is happening right here? Well, you have y prime goes from negative to 0 to positive. That means I was decreasing, then I was flat, then I was increasing. That is a local max. Hopefully you could identify that on your own. Sorry, that's not a max. That is a local. Whew, I did that once in class too. It is a local min. Maybe I'm just trying to keep you awake. Anyway, there you go. Our answer is here. This is usually the form I'm going to put it in. If you're interested, you're probably not. Notice how the signs don't alternate here. So a lot of people assume that these signs are going to alternate always. They don't. But this graph looks something like this. There's asymptotes at 2 and negative 2. And I'm pretty sure it goes something like this. And like this. Actually, this is a bit lower down. Anyway, it doesn't really matter. And something like this. So you can see it's decreasing. Is decreasing, then it's decreasing. It flattens out here. There's that local min we talked about. Then it's increasing and it's increasing. So even though there was a break in the graph because of the asymptote, it could still continue to increase. Anyway, there you go. I hope that was helpful, and we'll see you in the next video.